When it comes to volcanoes, there are actually two major types of eruptions. The first is called a non-explosive eruption. So this occurs when a relatively calm lava flows release large amounts of molten rock. And some of the largest mountains on Earth are actually grown from these repeated lava flows just over thousands and thousands of years, just constantly flowing down, cooling and hardening, and then more layers just building right on top of it. And a famous example of that is Kilauea in Hawaii. If you actually go, I believe it's Mauna Kea is one of the largest of these mountains. It's actually the largest mountain on Earth if you measure it from the base of it to the very top. So that would be an example of a non-explosive eruption would be in Kilauea, Hawaii. So you can see some more examples of this. Now, of course, there is some explosivity to it in the sense where, like, look how high this gets. I mean, I'm assuming this is several meters high. So, I mean, that's something. But it's not like the biggest eruptions that you've ever thought of. Those are not from these non-explosive eruptions. So that's what we're referring to. And you can see that there are different types of lava as they come out. You can have the really runny lava, like what comes out pouring out of here of Kilauea. I mean, that just, it looks as almost as smooth as water as it's falling down, right? So there's like a lava fall for you. Whereas over here, you have this blocky, chunky lava that takes a really, really long time for it to move forward. After that, we have our explosive eruptions. This happens or occurs when clouds of hot debris and gases, otherwise known as pyroclastic material, shoot out from the volcano at supersonic speeds. What does supersonic mean? Supersonic, so super is faster than or more than, and then sonic, it has to do with sound. So it means that it moves faster than the speed of sound. There's a video that is next where you can see the eruption, and then you wait a couple seconds and then you hear it, just in the same way that like thunder and lightning have that relationship, because the speed of sound, what you see, moves faster than the speed of light is faster than the speed of sound. So molten rock is blown into millions of pieces that harden in the air, and then those millions of tons of solid rock get blasted out from that volcano. So you can see here, there's like a whole city down here. I'll move my head up here. You can see the whole city is down here, and look how high that is. I mean, it's really reaching to like the top of the atmosphere, like as high up as it could possibly go, just billowing tons and tons of that pyroclastic material out of there. And here's that video I was talking about, volcano eruption that you see before you hear. A couple more examples here. You can actually see this time-lapse image as the clouds get moved by. And because of that, some of the pyroclastic material that gets up there, if the clouds are moving fast enough, I mean, they've found that pyroclastic material and those gases from a volcano, I mean, like in several countries over, like really, really far away, because it could just stay inside of the air, and then the wind can take it really, really far if it goes into some of those global winds. And you could see down here, I mean, this was once all one solid cloud here, and look how this volcano eruption just basically pushed away a hole inside of that cloud, and it reached the top of it, and it actually has this kind of like mushroom shape that, up there near the top. And that's what tends to happen when it reaches the top of the atmosphere. It has nowhere else left to go. It doesn't go any further than that, so it winds up scattering out there. So an example of an explosive eruption would be Mount St. Helens in the state of Washington, United States. So we can see over here, I mean, there was no footage from this. This happened in, I believe, 1980. And there was no cameras and video cameras that was recording it as a video, the actual eruption. Not that I've seen. But this is a time lapse, a bunch of pictures that they put next to each other. And when they combine it, shows you this GIF of it taking place. Now you can see that both things are happening. It's basically erupting out the sides. There's a landslide at the same time as it explodes outward this way. And you can see it has some information here. Within minutes, the eruption blasted away a whole side of the mountain. I mean, it just laid flat. Like the whole side is just gone afterwards. And 600 square kilometers of forest nearby just completely decimated, all gone afterwards. So that's the power of this very intense explosive eruption. Here's some footage to show you some explosive eruptions from the bird's eye view looking down. And you can see that there is what's called a volcano explosivity index, which ranks the most explosive eruptions that have ever taken place in history. And you can see what some of the ones maybe you've heard of, how they rank in terms of the most explosive ones that have ever been recorded. So the last thing to keep in mind is, where do volcanoes take place? So you can see over here, right? Like if you were to guess, like I normally have people come up to the board and like kind of point this out, but we have volcanoes located around here in Washington. There's one in Alaska. There's ones over here in Japan, like Mount Fuji, and Indonesia, and some of these islands over here. There's volcanoes all down here, down this coast. So the majority of volcanoes, not all of them, but the majority of volcanoes lie in what's called the Ring of Fire. And you can see over here, this right here, this blue line with all those red triangles to denote a volcano, is the Ring of Fire. There is also the mid-ocean ridge. We've already learned about the mid-ocean ridge, that it's the longest chain of mountains and it's all underwater. Yes, so that exists right starting from here at Iceland, goes all the way down here, and there's a lot of volcanoes there as well. But the majority of the ones over here, about 75% of all volcanoes, lie on top of the Ring of Fire. And it has to do with this plate specifically being consumed underneath these other plates and basically giving fuel to the rest of those volcanoes.